Hello, my precious friends. I really hope that you are doing great. Welcome to our today's class. It is our fifth lesson on the sixth topic of Form 4, which is called mains electricity. As usual, let me commence by giving the quote of the day, which states that success and failure are two sides of the same coin. We shall discuss that quote at the end of our class today. So today we are looking at electrical energy consumption and costing. So we shall basically be looking at how do you calculate the cost of electricity. So we are saying that the unit of electrical energy is what we call the kilowatt hour. That is the abbreviated as the kilowatt hour. Then we are saying that kilowatt hour is simply defined as the electrical energy spent in 1 hour at the rate of 1,000 watt. Therefore, this one simply means that 1 watt will be equal to 1 joule per second. Remember, we said that power is equals to work done over time. Therefore, the work done is measured in joules, then time is measured in seconds. Therefore, work done, which is in joules, divided by time, which is in second, that is the formula for the power. So the power in watt is equals to the work done in joules divided by the time in second. Therefore, 1 watt is simply equal to 1 joule per second. Or simply put, 1 watt is equals to 1 joule per second. Remember, S power negative 1 means that we are talking of joules divided by seconds. Therefore, if 1 kilowatt will be equal to 1,000 joules per second, which is simply equal to 1,000 watt, because remember, joules per second is simply work done divided by time, which are the units for power. So power is work done over time. Therefore, joules per second is simply power, which of course we know that the unit for power is actually the watt. Therefore, if you want to find the total energy spent, will be equal to 1 kilowatt hour, which is equals to 1 kilowatt multiplied by 1 hour. So remember, 1 kilowatt, that is simply power in kilowatt. And remember that 1,000 watt is equals to 1 kilowatt. What about 1 kilowatt? So 1 kilowatt is a power which is equivalent to 1,000 watt. Then the time in seconds, that is the 1 hour. If we convert that in seconds, remember that 3,600 seconds is equals to 1 hour. So what about 1 hour? So it will be 1 hour over 1 hour multiplied by 3,600 seconds. Therefore, 1,000 watt multiplied by 3,600 seconds, it will give you 3,600,000 watt seconds. So that is what we call the total energy spent. That is by 1 kilowatt. So remember, this one you can convert it to standard form. So it will simply be 3.6 times 10 power 6 joules. That is joules, or simply put, 3.6 megajoules. Then, if you want to find the number of units in kilowatt hour, you simply take the power in kilowatt hour, you multiply by the time when it is expressed in hours. So we are simply taking the power in kilowatt, then we are multiplying by the time when it is expressed in hours. So this is how we compute the number of units in kilowatt hour. Remember, if you check on the meter of your electrical, that is domestic electrical connection unit, you realize that you will find something written like kWh. So this is simply the number of units that you have actually spent, or that you have purchased for that particular case. So kilowatt hour are simply the number of units. So if you want to compute the number of units in kilowatt per hour, that is in kilowatt hour, you simply take the power expressed in a kilowatt, then you multiply by the time that is expressed in hours. Therefore, if you want to compute the cost of electricity, you simply take the number of the total number of units in kilowatt hour, you multiply by the cost per unit in kilowatt hour. Remember, different countries will have different costs for that is different cost per unit. Even in our country, Kenya, actually the cost per unit keeps on changing, of course, depending with the economic standards of such a given country. So if you want to compute the cost of electricity, this is the formula that you'll be using. You simply take the total number of units in kilowatt hour, then you multiply it by the cost per unit, that is in kilowatt hour. So remember, the total number of units in kilowatt per hour, that is in kilowatt hour, you simply take the power when it is expressed in kilowatt, then you multiply by the time in hours. Then of course the cost per unit in kilowatt hour, that is simply the cost per unit, because a unit will always be expressed in the units of kilowatt hour. Next, we look at our first example, which reads that an immersion heater which is rated 3,000 watt is used continuously for 45 minutes per hour, then per day. So we are told to calculate the cost per week at Kenya shillings 6.70 per unit. So this is the cost of electricity per unit. So we said that if you want to find the total cost of electricity that has been used, you simply take the total number of units in kilowatt hour, you multiply by the cost per unit in kilowatt hour. So the first thing, we need to identify the total number of units spent in this particular case, that is in kilowatt hour. So total number of units in kilowatt hour, you simply take the power in kilowatt hour, then you multiply by the time in hours. So the power that has been spent, we are told that an immersion heater, it is rated 3000 watt. Therefore, this is the power that is being used. So we are going to convert the power in kilowatt. And remember that 1000 watt is equals to 1 kilowatt. What about 3000 watt? So that will be 3000 watt divided by 1000 watt multiplied by 1 kilowatt. Then the time spent in hours, we are told that an immersion heater, which is rated at 3000 watt, is continuously heated for 45 minutes per hour per day. Therefore, the total time that has been spent, then you are told to calculate the cost per week. Remember, 1 week has 7 days, then each day has 24 hours. Therefore, if we want to find the total time that has been taken in this particular case, we are going to take the 45 minutes, of course we convert it into hours. Then that is 45 minutes per hour. So we're going to take 45 minutes multiplied by the number of hours that are in a given day, of course, which are the 24 hours. Then you multiply by, that is the cost per week. We multiply by the number of days which are within a week. So we are going to have 45 minutes. If we convert into hours, remember that 60 minutes is equals to 1 hour. What about 45 minutes? So that will be 45 minutes over 60 minutes multiplied by 1 hour. We are simply changing the time in hours. Then the cost per week, we know that, so the 45 minutes per hour, this one is for each day. Therefore, for a week, we are going to take the cost of 1 day multiplied by the number of days that are within a week. Then, of course, we know that a week has 7 days. Therefore, 45 over 60 times 1 hour. So this is the cost. Then, of course, 1 day has 24 hours. So this is the cost in 1 day. Then to find the cost in 1 week, we'll take the cost per day multiplied by the number of days within a week, which are the 7, of course, days in a given week. Then from there, we're going to multiply by the cost per unit in kilowatt hour. So the cost per unit is always expressed in kilowatt hour. We are given that the cost per unit is 6.70, that is per unit. So the cost per unit in kilowatt hour, we are given as Kenya shillings 6.70 per kilowatt hour. So if you take 3000 watt over 1000 watt multiplied by 1 kilowatt, of course 3 zeros will cancel out, so it will remain with a power in kilowatt of 3 kilowatt. Then if you take 45 divided by 60 multiplied by, of course, 1 hour times 24 by 7, you are going to get 126 hours as the amount of time that has been taken within that particular week. Then the cost per unit is 6.70 per, that is Kenya shillings per kilowatt hour. Then, of course, if you take 3 multiplied by 126 times 6.70, you are going to get Kenya shillings 2,532.6. Then, of course, because these are shillings, we express the last digit in cents. So this will be Kenya shillings 2,532.60 or and 60 cents. So that is the cost for operating that particular heater if it is being operated for 45 minutes per hour per day for 1 week, which has 7 days. Then our second example reads that a hair dryer is rated at 2.5 kilowatt, 240 volts. So part A, we are told to determine whether a 10 ampere fuse may be suitable for the hair dryer. So we're going to find the amount of current through this particular hair dryer. Then we know that from power is equals to VI. If we make current subject of the formula, current will simply be equal to power divided by the voltage. So we're given the power as 2.5 kilowatt. So 2.5 kilowatt divided by the voltage is 240 volts. Then of course, because I want to find the power, I'll express each quantity in its respective SI unit. Now the SI unit for power is simply the watt. Therefore, I'm going to convert the 2.5 kilowatt into watt. So we know that 1000 watt is equals to 1 kilowatt. What about 2.5 kilowatt? So that will be 2.5 kilowatt over 1 kilowatt multiplied by 1000 watts. So this is to convert the power into the SI units, which are the watts. Then of course, the voltage is already in its SI unit, that is the volt, which is 240 volts. So if you take 2.5 multiplied by 1000, we are going to get the power in SI unit as being 2500 watt divided by the voltage, which is 240 volts. So therefore, the current that the hair dryer is using will actually be 2500 watt divided by 240. You are going to get a current of 10.42 amperes. That is correct to 4 significant figures. Then you are told to determine whether a 10 ampere fuse may be suitable for this particular hair dryer. So because the amount of current that the hair dryer is using, which is 10.42 amperes, is larger than the fuse rating, which is 10 amperes, it simply means that this particular 10 ampere fuse will not be suitable for this particular hair dryer. The reason being, it exceeds the fuse rating. We said that the fuse rating should always be slightly higher than the amount of current being used. For example, a fuse that will be appropriate for 10.42 amperes current will be maybe a fuse of about 11 amperes. Therefore, a 10 ampere fuse will not be suitable for this particular hair dryer because the current that it is using, it exceeds the fuse rating given, which is the 10 amperes. Then Roman 2, we are told to determine the cost of using the hair dryer for 3 hours if the cost of electricity is 0.80, that is of course cents per kilowatt hour. So we say that to find the cost of electricity, total cost of electricity, you simply take the total number of units in kilowatt hour, you multiply by the cost per unit, which is always given in kilowatt hour. So the total number of units in kilowatt hour will simply take the power. We are already given the power as 2.5, which is already in kilowatt hour. Then the total time which has been taken, we are told for using a hair dryer for 3 hours. So the total time is 3 hours. Then we multiply by the cost per unit, that is in kilowatt hour. We are given the cost as 80 cents. So we're going to take 2.5 multiplied by 3, which is the power in kilowatt hour, then multiply by the cost per unit, which we are given as 0.80 or 80 cents Kenya shillings. So if you take 2.5 times 3 times 0.80, you are going to get the total cost of Kenya shillings 6. So we are going to get a total cost of 6 shillings. Next, we look at our third example, which reads that an electric heater is made of a wire of resistance 100 ohm and connected to a 240 volts main supply. Determine part A, the power rating of that particular heater. So remember, power is equals to V squared over R, because for this case, we are given the resistance, which is 100 ohm. Then we are also given the voltage, which is 240 volts. Again, we derived this formula in a given chapter in Form 3, which was called heating effect of an electric current. You can just review it. So power is equals to V squared over R. So the voltage we are given as 240 volts divided by the resistance we are given as 100 ohm. So this will be 240 squared. You will get 57,600 divided by 100 ohm, which is just 100. So this will give you the power rating of the heater as being 576 watt. Then part B, they want us to find the current flowing in the circuit. Again, we said that power can be given by VI. So if we make current subject of the formula, current will be power divided by voltage. So the power, of course, we have already computed it up here, which is 576 watt, divided by the voltage is 240 volts. So 576 over 240, you will get a current of 2.4 amperes as the current flowing through in the circuit. Then part C, we are told that to find the time taken for the heater to raise the temperature of 200 gram of water from 23 degrees Celsius to 95 degrees Celsius. Then we are given the specific heat capacity of water as 4,200 joules per kilogram per Kelvin. So this question is combining with the quantity of heat, whereby we are saying that the heat lost must be equal to the heat gained. Again, we covered quantity of heat in Form 3, so you can just check. It is a chapter that we discussed in details. So just go to Form 3 work and look at quantity of heat. We actually discussed such questions. Therefore, if we want to find the time taken for the heater to raise, we are going to use the relationship that the heat lost must be equal to the heat gained. That is assuming that no heat actually gets lost to the environment. So the heat lost by the heater must be equal to the heat gained by the water. So the heater, because the heater is the one that is supplying heat, therefore it is losing the heat, then that particular heat is being gained by the water. Why are we able to determine that water is gaining heat? Because the temperature of water is rising from 23 degrees Celsius to 95 degrees Celsius. And the quantity of heat, we said that whenever temperature increases, then it means that particular substance is gaining heat. But whenever the temperature of a substance decreases with time, then it means that substance is losing heat. Therefore, the heater is the one losing heat because it is applying the heat. Then the water is gaining the heat because its temperature is increasing from 23 to 95 degrees. So the heat lost by the heater, we are given the power rating of that particular heater, which we have computed in part A as 576 watt. Then we are also given the time. Sorry, we want to determine actually that particular time. So the time is our unknown in this particular case. Then heat gained by water is given by mc theta, that is mass of the water, multiplied by specific capacity of water times the change in temperature of water. We looked at this formula under quantity of heat. In case you are not familiar with it, just review our lessons in Form 3. We discussed quantity of heat in details. Therefore, the power rating we have computed in part A as 576 watt multiplied by the time, which must be equal to the heat gained by water, which is equals to mc theta. Mass of the water, we are given that the mass of the water is 200 gram. Of course, we convert the mass into SI unit. We know that the SI unit of mass is the kilogram, and we know that 1,000 grams is equals to 1 kilogram. So what about 200 gram? So this will be 200 gram over 1,000 gram multiplied by 1 kilogram, which would just be 200 over 1,000. Then specific capacity of water, we are given as 4,200 joules per kilogram per Kelvin, which is just 4,200. Then multiplied by change in temperature will simply be the difference between 95 and 23. So change in temperature will simply take 95 minus 23. Remember, when you are computing change in temperature, we don't look at the sign, so it has to be a positive value. So you simply take the larger value, then of course you subtract the smaller value. So we'll simply take 95 minus 23. So we are not interested, remember a change, we are not interested with the sign. We just need to know the difference between 23 and 95. Then under quantity of heat, we are able to prove that if you compute the change in temperature from 23 to 95, if it is in degrees Celsius, the change is just the same as when you express the value in Kelvin. In case, so we discussed this concept in under quantity of heat, that a change in temperature, even if it is in degrees Celsius, the change is its value will be the same as when it is in Kelvin. So don't wonder why I'm introducing Kelvin, yet we have degrees Celsius here. In case you are not able to understand, we discussed that under quantity of heat, so just review our lessons on that. You'll be able to catch up. So 95 minus 23 Kelvin. Again, I'm using Kelvin because those are the SI units for temperature. So 576 times T, you just get 576 T. Then 200 divided by 1,000, you'll get 0.2. Then of course times 4,200 times 95 minus 23, you'll get 72 Kelvin. So if you compute 0.2 by 4,200 times 72, you are going to get 60,480. If I make time subject of the formula, I'll divide both sides by 576. Therefore, the time taken for the heater to raise the water of 200 grams from 23 degrees to 95 degrees will be 60,480 divided by 576, which gives you 105 seconds. Then part D, they want us to find the cost of using the heater for 2 hours a day for 30 days. Then we are told that the power and the lighting company charges Kenya shillings 5 shillings per kilowatt hour. So of course the lighting company is the KPLC for the case of Kenya. In other countries, maybe you have different bodies governing or regulating the electricity. So we said the cost of electricity is given by the total number of units in kilowatt hour multiplied by the cost per unit in kilowatt hour. So the value that you are given, that one will always be the cost in a unit, and remember a unit is simply the kilowatt hour. So the total number of units in kilowatt hour, you're going to take the power expressed in kilowatt multiplied by the time expressed in hours. So the power in kilowatt, we already computed it up here, which was 576 watt. So to convert to kilowatt, remember 1000 watt is equals to 1 kilowatt. What about 576 watt? So that will be 576 watt over 1000 watt multiplied by 1 kilowatt. Then the total time in hours, we are told for using the heater for 2 hours a day for 30 days. Therefore, the total number of hours will be 2 hours multiplied by the number of days in 30 days. So we'll take the 2 hours multiplied by 30 days so that we get the total time taken by that particular heater for 30 days. So total time taken will be 2 hours times the number of days, which is 30. So 2 times 30. Then times the cost per unit in kilowatt hour. Of course, we are given as 5 Kenya shillings. So times 5 Kenya shillings. So if you compute 576 over 1000 times 2 times 30 times 5 shillings, you are going to get the cost of using the heater, the total cost for using the heater as Kenya shillings, 172 and 80 cents. Lastly, I have an exercise that I recommend that you should try at your own free time to get the understanding of the concepts that you have just learned. Of course, if you have any challenges in handling any of the questions, feel free to drop a comment specifying the question that you need help in. And as usual, I'm always here to try and help where possible. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that success and failure are 2 sides of the same coin. So the quote is reminding us that failure is an essential component of success. Therefore, there can never be true success without encountering some elements of failure. I remember when I was a student at Form 2 level, I once scored a 0.8 out of 30 in mathematics in a continuous assessment test, which is commonly known as the CAT. And also, I scored a 0.6 out of 70 in the end of term examination. But the funny thing is that today, I'm a teacher of mathematics and physics. So this shows you that it does not matter how you started. The most important thing is believing in yourself, having a positive attitude towards everything you do, and more importantly, taking action towards achieving your desired grades. And lastly, recall that anything is possible provided that you are willing to put in your time, you are willing to put in your energy, and you are willing to put in your resources. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.